Okay, so to discuss range, the first thing we need to revisit for any angle theta, again with a point xy on the terminal side, we know that the relationship between x, y, and r is x squared plus y squared equals r squared. If we rewrite that, r is basically the square root of x squared plus y squared. Right? And what this basically implies is that our r value will always be bigger than or equal to x. Of course, if y is equal to 0, r will equal to x. If y is not equal to 0, we're adding a little bit something, taking a square root. It's going to, that value will be bigger than whatever x or y will be. Vice versa. If x is equal to 0, r is equal to y. Right? If we have a value for x, then x squared plus y squared square root, right? That r value will be bigger than what y could be. So that's really important for what we're about to say here, right? Because we know, right? Thinking of domain, thinking of range, right? What does the output for sine defined to be? Well, it's defined to be y over r. All right, and this is always positive, and this can vary between positive and negative values. All right, so we know we can be positive or negative. However, we also know that r is bigger than or equal to y. All right, so that is basically a known fact. And so if we divide both sides by r, we get that 1 is greater than or equal to y over r. And of course, that's our definition for sine. So that means that 1 is greater than or equal to the sine of theta. All right. Of course, if this was negative, right, we would basically have, if if we threw some negatives in here, right, we would have, again, if we throw a negative, we have to flip the sign around. Right, and again, y is negative in this case. All right, and so again, that's our sine value. So negative 1 is greater than or equal to sine theta. So negative 1 is less than sine theta, or 1 is greater than sine theta. So if we actually put these two together, what we have is that the sine of theta basically sits anywhere between negative 1 and 1, or just using our definition, the ratio y over r will always sit between negative 1 and 1. So the range of sine, if I had to put it in interval notation, you can put any angle you want. That's our last discussion, right? So you can put any angle you want in for sine, but you're only going to get something between negative 1 and 1 for sine. Right? And then it turns out that cosine is very similar. Right? We can almost have the same exact argument, and I'll do it a better way here. Right? So we know that x is less than or equal to r. Right? And if I divide both sides by r, this means that x over r is less than or equal to 1. So that basically means my cosine of theta, right, is less than or equal to 1. Accounting for a negative, right, that basically means that negative x over r is greater than or equal to negative 1. All right, so we have it this way then, right, kind of flip-flopping it around. So again, cosine, right, like sine, has a very restricted range, and that's kind of odd, right? Because usually when we have a function that is very strong, you put whatever you want. You'd expect the range to be a little bit bigger, right? But it's not. So sine and cosine is restricted between negative 1 and 1. All right. So what about? Let's go look at my tangent function, right? The next big function that we got. Well, by definition, tangent, right, is y over x. All right, so again, these can run the gamut. This could be negative, this could be positive, this could be negative, this can be positive. So we can get any positive or negative ratio out of this. All right, and then a little harder to kind of think about, but if y is big and x is small, we get a very big number, right? And we're kind of getting in the concept of limits. So tangent can pretty much approach positive infinity if I let y be big and let x get smaller and smaller and smaller, which is very doable in terms of a terminal side. It is possible to have y equal to 1,000 and then x equal to 0.0001. All right, and so we're going to get a very big number, and of course we can make this larger, we can make this smaller. We're approaching infinity. Of course, that's the positive sense. What about the negative sense? Well, that means that we can approach negative infinity as well. All right, and then we can be everybody in between. Of course, we have to worry about, right, x not being 0. But if y, right, is a small number and x is now a big number, then this is going to be really, really close to 0, right? So it's going to be fractional, maybe a half, maybe 1/3, 1/4, 1/5. Right here, what I'm doing is letting the y value be 1, and I'm letting the x value get a bit larger and larger and larger. So we're getting smaller. And of course, that happens on the negative side. So in net effect, because y and x work that way, right, it looks like tangent, right? It is a fact that the range for tangent is actually everything. All right, so as long as we avoid those 90-degree and 270-degree angles, so the range is anything. So anything can come out, any ratio can come out, any real number. So there you have it. And then of course cotangent of theta is going to be very similar, because all we're doing in cotangent is we're just basically flip-flopping the y and the x. So the same argument is going to happen, right? X is big, y is small, x is small, y is big, right? It's going to basically have the same argument, all right? So cotangent and tangent are very similar, and that their output values, no matter what angle you put in, it will always create some output, right? There's going to be some range value for any angle you put in, again, assuming it's not an angle where x is 0 and y is 0. All right, so there's that. All right, and then the next one, right, is let's go ahead and consider our cosecant of theta. Well, by definition, right, cosecant of theta is r over y. Right, and what do we know? We know that r is actually bigger than y. All right, and so if we divide both sides by y, right, we get that r over y, right, is bigger than or equal to 1. And of course, r over y, that's our cosecant. So we've just found out, right, that cosecant will be larger, all right, than, all right, positive 1. All right, of course, we can also consider their negatives. If y is negative, right, we introduce a negative which flips the sign around. And so our negative cosecant, or our cosecant value for that, right, will be actually less than or equal to -1. So if I was thinking in terms of range, this basically means from 1 to -1, outputs are happening this way and outputs are happening that way. So it's unlike with a sine and cosine where we can actually put them in one interval. We actually need two. So the range for cosecant is from 1 to infinity, right, or from -infinity to -1. So it's got a little bit of a gap. And that shouldn't surprise us, because I think I've alluded to the fact that sine and cosecant, right, they're reciprocals of each other. And you can kind of see their ranges are almost reciprocals of each other, right? What the output for sine isn't, missing from the output for cosecant, and vice versa. It has a lot to do with the reciprocality going on. And of course, we can have the same argument, all right, for secant, right? Secant of theta, by definition, is r over x. And then we just replace my y's with x's, and we got it, all right? So it turns out, to make a long story short, right, that the secant of theta, no matter what angle you put in, you're going to get something that's less than -1, or you're going to get something that's greater than +1, no matter what the ratio is. All right, so there's basically your range values for these guys. Now that we've kind of looked at that, hopefully you can kind of understand the argument with the x, y, r definition. But I promise you, as we learn new definitions, as we learn new things about sines, cosines, and tangents, as we start graphing them, or in Chapter 4, hopefully these ideas will start together. All right, so what can I put in them? What comes out of them? Right, there's your initial look at that, domains and range of our trig functions. All right, I'll talk with you guys. Oh, by the way, real quick too, we got to get used to the fact as well, I should have said this at the very beginning, we're used to x being an input and y being an output. X and y are now part, all right, of the output here by the definition. It's the angle that serves as the input and some ratio of x, y, r that's creating the output. So we have to kind of extend our limited knowledge, if you would, of functions, right? Because we're still using the concept of function, something in, one thing out, but we're no longer using x and y as input and output. Theta is the input, and some ratio of x, y, and r is the corresponding output. So be aware of that central figure here. All right, so let's go do some homework problems.